Hello everyone, and we're now on question 3 on mechanics from 2023 for A-Level Edexcel. At time t seconds, where t is greater than or equal to 0, a particle has a velocity of v meters per second, where v is equal to t squared minus 3t plus 7i plus 2t squared minus 3j. Find the speed of p at time t equals 0. So the key word there is the word speed, and speed is the magnitude of the velocity. So, and it's at time t equals 0, so we're going to have 0 squared minus 3 times 0 plus 7, and we're going to have 2 times 0 squared minus 3. So we end up with 7 squared plus minus 3 squared, which is 49 add 9, so that is root 58, which as a decimal is 7.62 meters per second to 3 significant figures. Part B. Find the value of t when p is moving parallel to I plus j. Okay, so I think a little sketch is really useful here. So if something's moving in the direction of I plus j basically means that you've got the I component is equal to the j component. So that means it's essentially moving along the line y equals x. It could also have said minus I minus j as well, which would have been a point on the same line. So it says I plus j, so therefore it's on the line y equals x, which basically means that the j component is going to equal the I component. So when you see that I plus j, you're going to set the I and j components equal to each other, and in so doing then solve for t. So let's do that then. So we've got t squared minus 3t plus 7 is equal to 2t squared minus 3. So we're going to take t squared off both sides, giving us 1t squared, add the 3t across to the other side, take away the 7, and that gives us t squared plus 3t minus 10 equals 0. This can be factorised now into t plus 5 and t minus 2, which gives us solutions of t equals minus 5 and t equals 2. But we're told in the question that t is greater than or equal to 0, so we discount that solution, and the answer is t is equal to 2. Part C. Find the acceleration of p at time t seconds. So acceleration is equal to the derivative of the velocity. So we need to differentiate the velocity. So when we differentiate our t squared, we get 2t. Minus 3t goes to minus 3. The 7 disappears. For the 2t squared minus 3, 2t squared goes to 4t, and the 3 disappears. So that is our answer. A is equal to 2t minus 3i plus 4tj. Last bit of this question then, it's working out nice so far, this paper. It says, I've probably spoken too soon, it says find the value of t when the direction of the acceleration is perpendicular to I. So let's draw a little diagram to see what's going on. So there's a line that is perpendicular to I. Now, it's not very obvious, I think, this, but basically if something's perpendicular to the I, then what that means is it's only the j values that are changing. So the I just remains constant. So basically the j values are what's changing to navigate up and down that line. So what you have to do in that situation is it means that the velocity is moving totally up or totally down. So the velocity has a 0 I component. So you set, now don't be confused about the fact that you can see it, you might say, well, it looks like it's got an I component because it's there, but it's about the direction that it's going, okay? So the direction that it's going straight up or straight down, and something can only be going straight up or straight down when the I component is 0, okay? So when they say that it's moving in a direction that's perpendicular to the I axis, it doesn't matter where it's happening, it's to do with the vector of its motion. And the vector controlling its motion, if it's going straight up and straight down, has a 0 I component. So in order to work out what that is, we set the I component equal to 0 and solve for t. So that would be 2t, take away 3 is 0, so t is 3 over 2. Okay, I hope you found that helpful, and I'll see you in the next video.